We are now going to look at an Excel example of testing for two population proportions. So here let's look at the example from the textbook. Here we have two different holiday hotel resorts, Beachcomber and Windsurfer hotels. So here the property management would like to understand or would like to study whether there is a difference in the way the guests feel after they have stayed, after they have spent their time. So at the time of departure, they want to ask them whether they will return for another time in the future. And is there a difference between these two hotels? Okay, to see whether the guests have the same impression about their stay between the two hotels or not. So we take a random sample of, say here, from the first hotel, which is Beachcomber. Okay, the respondents of 227 guests at Beachcomber and 262 guests at Windsurfer. And when you ask them, and their response was 163 of the 227 responded yes, they would return. And 154 of 262 in the Windsurfer responded yes, that they would return. So now we want to test whether the true proportion of guests who would return, okay, is it the same for the two hotels or not? So let's define these concepts and do the test. So let's go to Excel. So in this sheet, I have the general concepts described here from the PowerPoint file. So the two population proportions, the three flavors of the hypothesis test, and the sample notations and so on. Okay, but here we're going to look at the particular example. So here we define success as a guest expressing a willingness to come back. Okay, so likely to return. So pi sub 1 is the proportion of guests likely to return in Beachcomber Hotel, and the same for Windsurfer, pi sub 2, and we want to test whether these two proportions are same. Okay? As against the alternative, they are not. And let's test at 5% level of significance. So now if the original raw data is given, we can develop these statistics using count and count if. But here we have the n sub 1 and x sub 1s already given to us. Okay, so these are 227 guests. Of that, 163 said that they would return for Beachcomber. And for Windsurfer, 262 guests were sampled and 154 said that they would. And then P sub 1 is x sub 1 divided by x sub 2. Same over here. And you see number of successes is 163 and 154, and the number of non-successes would also be greater than or equal to 5. So for samples to be large, considered large, the number of successes, x sub 1 and x sub 2, as well as the opposites, are both 5 or more. So no assumption is necessary. We can safely use Z statistic or Z test. So now we start with pooled proportion P bar. Okay, and once again, like I have done previously, it is a good idea to split up complex formulas into smaller pieces. So here we can go n sub 1 plus n sub 2. Okay, so like that, we'll call that sum. Okay, if we copy that down here, so this will be x sub 1 plus x sub 2, and that is n sub 1 plus n sub 2. So our pooled P would be that divided by that. Now standard error of estimate, okay, for test, so I have the formulas given here. So let's move the formula down where we can see and we can set up the formula. So the standard error is square root of, okay, so we have P sub P bar, so which is that, times 1 minus P bar times 1 over n sub 1 plus 1 over n sub 2. So we need one more right bracket. So that gives us the standard error, and then the z stat would be P bar sub 1 minus P bar sub 2, okay, and minus 0. Okay, the right hand side here is 0, so we'll skip that part, minus 0, you don't have to do that. Yeah. And then divide by the standard error of estimate, so that gives you the z statistic. And the z table, norm dot s dot inv. Okay, so we need to provide the cumulative probability. If you want the right side, the positive value for z, so we need to provide the cumulative probability, and cumulative probability, the top tail area is alpha over 2. So the cumulative probability is 1 minus alpha over 2. So if you go 1 minus alpha over 2, so that will give us the positive side. So then our rejection would be if the absolute value of the z statistic is greater than the z table value, we will reject. So conclusion is we reject, because the absolute value of z is greater than that, so we reject. The p value is, again we need to do norm dot s dot dist. Okay, so now we need to provide, okay, so we want the tail area, right, and then the z value could be positive or negative. So if we force it to the positive side, so that would be the absolute value of the calculated z. All right, so that would be always on the positive side. Okay. Now, norm dot s dot dist will give you the cumulative probability. So in the normal distribution, it will give you the cumulative probability. But what we want is the tail. So we need to do really 1 minus this. Okay. So well, before that, let's put the 1 cumulative probability. But this is not the tail area. So we need to go back and adjust that to 1 minus that. So that's the tail area. Okay. And we are still not done, because this is a two-tail test. So the actual p-value is 2 times the upper tail area. So we need to put brackets around this and then multiply by 2. So that will give us the p-value. So obviously the conclusion is to reject. P-value is less than 5%, so we reject. Then we do the interpretation. So we do have sufficient evidence to conclude that the proportion of guests who are expressing a willingness to come back, okay, is not the same between the two hotels. So further investigation is necessary. What is the one where more people are willing to express a willingness to come back? What are they doing right, and what are these people not doing right, and so on. So this is a starting point. It gives us sufficient statistical valid evidence to pursue this further.